Hello everyone. In this video, I will be talking about systems of particles and rotational motion. In this video, I will be talking about equilibrium of a rigid body, the moment of inertia, the radius of gyration. First, we can see what you mean by the equilibrium of a rigid body. A rigid body is said to be in mechanical equilibrium if both its linear momentum and angular momentum are not changing with time. Or equivalently, the body has neither linear acceleration nor angular acceleration. This means that the total vector sum of forces acting on the rigid body is 0, and also the total vector sum of torques acting on the rigid body is 0. That is, the rigid body is stationary. Now, couple. Couple is a case of partial equilibrium in which there is no translational motion but there is only rotational motion. Examples of couples include the motion of the lid of a vessel, of a bottle, that we are opening by rotating the lid. Now, this is a figure showing a rod in which two equal and opposite forces are acting on both the sides of the rod. A pair of equal and opposite forces with different lines of action is known as a couple. A couple produces rotation without translation. Since the forces are equal and opposite, there is no translational motion. Only rotational motion occurs. That is, only torque is experienced by this rod. Now, principle of moments. For this, consider a lever which is pivoted at a point O by a fulcrum. The forces acting at both ends of this rod are given by F1 and F2, and R is the normal reaction. Now, for translational equilibrium, R minus F1 minus F2 is equal to 0. And for rotational equilibrium, D1 F1, which is the moment, minus D2 F2, since the torque is in the opposite direction. That is, in this case, the torque in the clockwise direction is considered as negative, while the torque in the anti-clockwise direction is considered positive. Hence, D1 F1 minus D2 F2 is equal to 0. That is, sum of moments is 0. From this, we can reach this equation. That is, D1 F1 is equal to D2 F2. That is, if D1 is the load arm, that is the distance at which the load is kept from the center O at point A, that is D1, and F1 is the load, and similarly the effort arm which is D2, which is the distance from the fulcrum O to the other end B, D2, and the effort F2. Now, mechanical advantage of this lever is given by F1 by F2 is equal to D2 by D1. If D2 is greater than D1, then the mechanical advantage will be greater. That is, the force required to lift a load will be much lesser, or the effort will be required will be lesser. Hence, mechanical advantage will be higher. Now, center of gravity. The center of gravity of a rigid body is defined as that point where the total gravitational torque on the body is 0. Center of mass and center of gravity are two different concepts. In the case of center of gravity, the torque acting on the different particles of the rigid body cancel out. If the acceleration due to gravity is the same for all particles of a rigid body, then the center of gravity coincides with its center of mass. That is, when the rigid body is kept in a uniform gravitational field, center of gravity will be equal to the center of mass. Now, moment of inertia. Moment of inertia is the property of an object by virtue of which it opposes a change in its state of rotation about an axis. This is analogous to the concept of inertia in the case of translational motion. Now, the moment of inertia of a body about a given axis is equal to the sum of the products of masses of its constituent particles and the square of their distance from the axis of rotation. In this case, moment of inertia can be considered similar to mass. Now, moment of inertia I is equal to m1r1 square plus m2r2 square plus m3r3 square plus mn square, which is the sum of all the moment of inertia of the system of particles. Hence, we can define moment of inertia is equal to sigma I is equal to 1 to n mi whole square. The moment of inertia of a body depends upon the position of axis of rotation, orientation of axis of rotation, shape and size of the body, and distribution of mass of the body about the axis of rotation. Its unit is kilogram meter square. Now, radius of gyration. It is the root mean square distance of a body's constituent particles from its axis of rotation. K is equal to root of r1 square plus r2 square plus r3 square plus etc. to rn square by n, where r1, r2, r3 etc. to rn are the distance of each of the system of particles of the body from the axis of rotation, and n is the total number of constituent particles. Now, theorem of perpendicular axis. This is a planar body. That is a rigid body. In this case, the moment of inertia of a planar body about an axis perpendicular to its plane is equal to the sum of its moments of inertia about two perpendicular axes concurrent with perpendicular axis and lying in the plane of the body. That is, in this case, Iz is equal to Ix plus Iy. Now, theorem of parallel axis. The moment of inertia of a body about any axis is equal to the sum of the moment of inertia of the body about a parallel axis passing through its center of mass and the product of its mass and the square of the distance between the two parallel axes. Here, A is the total distance between the two parallel axes. Hence, here I at z dash is equal to I at z plus m a square. So this is the end of this video. In this video, I have talked about some of the important concepts about equilibrium of a rigid body, moment of inertia, center of gravity. If you have got any doubt in any of the topics discussed in this video, please comment in the section below. Thank you.